Topic 2.8, the product rule, and topic 2.9, the quotient rule, is what we're going to explore today. So recall with the sum and differences, you can take the derivative of each of them and then add and subtract them. However, that is not true for multiplication and division. I'm not going to do any proofs of these rules. If you want to see the proof, you can scan this code and watch the proof of the product rule. We're just going to learn how to do the product rule and how to memorize it. So it says the product of two differentiable functions. So if this function and this function are both differentiable, then the product itself is differentiable. So this is the product rule right here. And basically what this says is if you have a first function times a second function, the product rule to memorize is the first times the derivative of the second plus the second function times the derivative of the first. So I wrote that up here for you. So memorize the first function times the derivative of the second plus the second times the derivative of the first. Okay, so we just have to memorize. So let's go ahead and try this on h of x. If you want to stop the video and try it on your own, you can do that now. Okay, so here we go, the product rule. The first times the derivative of the second plus the second times the derivative of the first. And that's the product rule. That's the calculus. The rest is algebra. Now we have to simplify. Distribute the 4, FOIL, and combine like terms. X squareds we have a negative 24x squared. Combine the x's and the constants. And that's your answer. Now, do we have to use the product rule in example number 1? Have we done problems like this in the past? Another option would be to FOIL this out first. So we could start with h of x, FOIL, you get 15x plus 12x squared minus 10x squared minus 8x cubed. So if we combine like terms, that's negative 8x cubed plus 2x squared plus 15x. So we could multiply them together and then use our power rule. Negative 24x squared plus 4x plus 15. And you have the same answer. So I like this method better. If you can avoid the product rule, I would avoid the product rule. But that's not always the case. So let's take a look at letter A. You have to recognize that this is a product. X times the sine of x. So we have to use the product rule. If you want to pause the video and try the product rule for practice, I would recommend. Okay, so here we go. F prime of x equals the first times the derivative of sine, which is cosine. You should have that memorized, plus the second times the derivative of the first. which is 1. So your answer is x cosine of x plus sine x. Go ahead and try B. Stop the video and try B. And now check your answer. First times the derivative of the second plus the second times the derivative of the first. Or you can also factor out an e to the x and have the answer of 1 plus x. Now these are multiple choice questions, so you just have to make yours look like one of the choices. Either one of these is acceptable. You don't need the 1 here if you don't want to write the 1. Okay. The next one I'm going to do is D. So go ahead and stop the video and try D on your own. Okay, let's check your answer. The first times the derivative of the second, you have to memorize that as 1 over x plus the second times the derivative of the first. So simplify, you have, I'm going to put the 2x in the front just so we don't get confused with this product here, 2x times the ln of x. Or another possible answer on the multiple choice could look like this. Okay. All right, let's try C. This one's a little bit harder. You have a 2 times an x times a cosine x. Many times we ignore the 2 and then we take the derivative of this and then we multiply everything by 2. Like over here. We take the derivative of sine x and we multiply it by -2 because that's just a coefficient. And this is a coefficient as well. But the difference between this one and this one is we could use this as our first function and we could just use it in our product rule, which makes the problem easier than if you just multiply your product rule if you multiply your product rule by 2 after, it's going to be a little bit more work. So my suggestion here is if you can put your coefficient with one of your factors, then this would be our first function and this would be our second function for the product rule. And you have to recognize that that is a product. Okay? This is a product. You could use the product rule with 2 and sine x, but the derivative of 2 is just going to be 0. So you're wasting your time using the product rule when you have a coefficient. You can just use our coefficient times the derivative of sine x. So go ahead and stop the video and try letter C. And now let's check your answer. H prime of x equals the first times the derivative of cosine. Negative sine x. Are you okay with me putting that negative in the front? First times the derivative of the second plus the second times the derivative of the first. I'm just going to put that in the front. Now, take the derivative of 2 sine x. So we're going to multiply the derivative of sine x by -2. Derivative of sine x is cosine x. So again, memorize. Derivative of cosine x is negative sine x. The derivative of sine x is positive cosine x. Don't get those confused. These two cancel out. Your final answer is -2x times the sine of x. And that's the product rule. Okay, let's move on to the quotient rule. The quotient rule is the one that you want to avoid using at all costs, because it's a lot to memorize, but you still have to memorize it. This is the quotient rule. Again, if you want to see the proof, just go ahead and scan that. The quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom. all over the bottom squared. Okay, so when I say top, I mean numerator. When I say bottom, I mean denominator. So memorize it however you would like, but again, it's here. It's the denominator times the derivative of the numerator. So I will say bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So memorize, repeating it over and over again. So let's go ahead and find the derivative of y. Another notation for y prime is dy dx. So you need to know that that is the derivative of y with respect to x. So that's what we're going to do. We have a quotient here. So let's do that together. So here we go. The bottom times the derivative of the top minus the top times the derivative of the bottom. And don't forget, it's a common mistake, don't forget your denominator, all over the denominator squared. And that is the quotient rule. The rest is simplifying using algebra. You want to go ahead and stop the video and simplify, practicing your algebra skills. Be very careful. This is a negative that needs to be distributed. The other common mistake is people will switch these around, and you can't do that. Make sure you follow the order so you don't make those common mistakes. Now you don't have to simplify your denominator. You can just leave it. So your final answer is negative 5x squared minus 4x minus 5 all over x squared minus 1, the quantity squared. Okay, find the equation of a tangent line. Think, what do I need? You have to ask yourself, what do I need to find the equation of a tangent line? And you should say, I need a point, which is right here, and what else? A slope. I need a point and I need a slope. How do we find a slope? What does slope mean in calculus? Tangent line slope. In calculus, what does that mean? It means find the first derivative. So we're going to find the first derivative of y. Again, notation for the first derivative of y is dy dx, or y prime. And again, we have a quotient here. So we're going to use the quotient rule. So why don't you practice the quotient rule on your own? Stop the video and see if you can do the quotient rule on your own. Okay, let's check your answer. Bottom times the derivative of the top. Whoops. Minus the top times the derivative of the bottom all over the bottom squared. Memorize, memorize, memorize. Now, on example number 3, we simplified it first. I'm going to give you a suggestion to save you time. If you're going to find a derivative and you're going to evaluate that derivative at some x value, plug in the x value before simplifying, and you will save yourself time in the long run. So again, this was just finding the derivative. This we need to find the derivative evaluated at 1. So I'm not going to simplify this. I'm just going to evaluate it at 1. Let me show you the notation for that you need to understand. I'm going to evaluate the derivative. I'm going to evaluate that at x equals 1. That's like saying, what is f prime of 1? But we don't call this f of x. They call it y. So we're just using the notation that's given to us. It's not in function notation. So we're going to use this notation. Evaluate the derivative at x equals 1. So you have to understand that that's what that means. So I'm going to go ahead and plug in 1 before I simplify. So 1 plus 1 squared times e to the first minus e to the first times 2 times 1 all over 1 plus 1 squared, the quantity squared. All right, so simplify that. What is that equal to? You should get an answer of 0 over 4, which is just 0. So think about what that means. If I have a first derivative at x equals 1 equaling 0, what does that tell you? What does that tell you about the graph? You need to know the first derivative equal to 0 is where you have what? And the answer is a horizontal tangent line. So if I say find a horizontal tangent line, you set your first derivative equal to 0. If I say the first derivative is equal to 0, you need to know that that's where the graph will have a horizontal tangent line. So if the graph has a horizontal tangent line, at this point, we have a point and we have a slope. So normally we would say, okay, let's use point slope. Y minus our y value equals our slope times x minus our x value. Now, if that was a free response question, that would be an acceptable answer. But you don't have to do that, and that's not going to be the multiple choice answer. If you have a horizontal tangent line at this point, you should know what the equation is. Horizontal tangent line, horizontal at this point has to be this. And that would be the multiple choice answer. If you simplified this, you would end up getting this. It would just take you longer to get there. We're trying to save time on the test, so be smart. Okay, so we've done these in the past. Recall when we did the power rule, I told you that you cannot take the derivative of the top divided by the derivative of the bottom. And you have to use the quotient rule. So if you take the derivative of the top divided by the derivative of the bottom, you're going to get the wrong answer. So don't do that. We want to avoid the quotient rule whenever we can. So what I told you back in section 2.5 and 2.6 was that if you can get rid of any product, like we did in example number 1, if you can get rid of any product or any quotient, that would be the first thing that I would do, because it's going to save you time. You can use the quotient rule in each one of these, but I would not. Time is of the essence. So can you rewrite this so it's no longer a quotient? Monomial denominator, monomial denominator. Do not use the quotient rule. It just is going to take you longer. So if we rewrite this, 6 is the common denominator. So I have x squared divided by 6. I prefer to write it as 1/6 x squared. That's just my preference. This is 3x divided by 6. I prefer that to write that as 1/2 x. So when I differentiate it, I can see that I'm just using the power rule. So 2 times 1/6 is 1/3. And then the power rule for this, or the derivative of x, is just 1. Okay? So that is your simplified answer. For this one, again, I don't want to use product rule, so I can just distribute negative 9x plus 6x squared over 7x, and I don't want to use quotient rule. So again, let's go ahead and split it up, rewrite it. And again, my preference is to write it on the side instead of writing it on the top. It's just personal preference. Now take the derivative. The derivative of a constant is 0, and the derivative of x is 1, and that's times 6/7. Again, so that's your simplified answer. Okay? Now notice this derivative has an x in it, and this derivative does not have an x in it. Why is that? Well, this is the derivative. This is the slope formula. Think of it as the slope-producing formula. So if I wanted the slope of the tangent line at 1, I would plug in a 1, and that would give me the slope of the tangent line to this. Now look at this. This is a quadratic. So as the x changes, the slope of the tangent line is going to change. So this is the slope, the derivative of the slope of the tangent line, the derivative of the function, which produces the slope of the tangent line at any x. But this one doesn't have an x in it. So what does that mean? That means this is going to be the slope of the tangent line for all x, which means this must be a straight line. Isn't this a line? Isn't the slope 6/7? So every point on this line has the same slope, has the same tangent line. That's why the derivative is always equal to 6/7. Just something to think about. All right, let's look at some AP questions. Okay, in AP, you cannot avoid using the product and quotient rule. You can't avoid it on some problems. Like this one. They don't tell us what f of x and g of x are. They just give us a bunch of information here, and they tell us that f and g are differentiable, and that's it. So let's go ahead, stop the video, and find the derivative of h of x. Check your answer. H prime of x is the first times the derivative of the second plus the second times the derivative of the first. Product rule. Okay, now find h prime of 3. Again, stop the video at any time. Do it on your own for practice. F of 3 times g prime of 3 plus g of 3 times f prime of 3. Do you know how to read the table and find those values? F of 3 is 1. G prime of 3 is -4. G of 3 is also -4. And f prime of 3 is 8. So that is a -4 plus -32 for a total of -36. Now, the applications of all of this will be coming in the next unit. Right now, we're just practicing basic rules that you need in order to do the applications. So that is coming. Okay, let's take a look at B. Look at this notation, a little bit different. What does this mean? This means find the derivative of this product. Find the derivative. It's basically saying that y is equal to the square root of x times f of x. That's what it's telling us. That this is our y value, and this is saying take the derivative of our y value with respect to x. So it's asking you to take the derivative of our y with respect to x. So some people don't like how I jump from this. How do I know that this means this? Again, this is telling us that this is your y value, your y function, and they want you to find the derivative of the y function with respect to x. So this is the proper notation. dy dx is what you're finding. So go ahead and try the product rule on your own. Check your answer. The square root of x, the first, times the derivative of the second, plus the second times the derivative of the first. You should have memorized the square root rule. 1 over 2 square roots of x. Now, over here, we wrote h prime of 3. Well, we can't really write dy dx prime of 4. That's not how we write it when it's in this notation. So here is the notation that you need to understand. Again, I did this before on the last page. dy dx, if you're evaluating it at 4, what would the notation look like? dy dx evaluated at x equals 4. That's like saying h prime of 4, but with a different notation. So you have to be familiar with all of the notations and what they mean. Okay, so let's go ahead and evaluate that. The square root of 4 times f prime of 4 plus f of 4 times 1 over 2 square roots of 4. So go ahead and find those values and see what you get. Stop the video at any time to work it out. So these are the values you should come up with. That's a -2 plus 5/2, which is +1/2. Okay? Reading a table. All right, last one. Practicing the same thing with the quotient rule. I would try these on your own, turn off the video for a while, try them on your own, and come back and check your answers. All right, checking your answer. H prime of x equals the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. We're evaluating that at 2. So g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. So that is 3 times the -1 minus 4 times 3/2 divided by 3 squared, which reduces to -9 over 9, which is equal to -1. Got -1, good job. If not, check your numbers, check your formula. Okay, on B, j prime of x, the bottom times the derivative of the top minus the top times the derivative of the bottom. Again, square root rule, 1 over 2 square roots of x. Do not use the power rule. This square root rule will save you time. All over the denominator squared. When you square a square root, it goes away. So we are evaluating that derivative at 4, the square root of 4 times g prime of 4 minus g of 4 all over 1, or times, 2 square roots of 4 all over 4. And for that, you should have gotten 2 times 1 minus 5 times 1/4, all divided by 4, which is 2 minus 5/4 divided by 4. That is 8/4 minus 5/4. So 3/4 on the top divided by 4 is 3/16. And there you are.